To create a truth table for a PL formula, you provide the truth value of that formula on every possible valuation of its atoms. If there's just one atom, then of course there are just two possible ways of assigning truth values to it. It can be true or it can be false. If there are two atoms, then it's fairly easy to see that there are just four possible ways of assigning truth values to them. The four possibilities are true, 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 false, false, true, and false, false. But what if the formula for which you want to create a truth table has three atoms, or four, or God forbid, even more than four? Then how do you figure out all the possible ways of assigning truth values to those atoms? Let's start with the case where the formula has three atoms, say P, Q, and R. What are all the possible valuations of those atoms? One way to figure that out is to see yourself as first making a decision about what truth value to assign to P. There are two options. You can make P true or you can make P false. To represent those two options, we could start a little tree with two branches. At the end of the left branch, I'll write PT to represent the situation where you choose to make P true, and at the end of the right branch, I'll write PF to represent the situation where you choose to make P false. After you make a decision about what truth value to assign to P, you next have to make a decision about what truth value to assign to Q. So suppose you make P true, you then have to decide whether to make Q true or false. So we should extend this leftmost branch of the tree by forking it off into two more paths. One to represent the scenario where after making P true, you make Q true, and the other to represent the scenario where after making P true, you make Q false. Alternatively, suppose that you first decide to make P false. Next, you still have to decide whether to make Q true or make Q false. So there are two separate paths you can go down from this point too. Let's add those to the tree. Finally, after you make a decision about P and about Q, you have to decide what truth value to assign to R. So suppose you make P true and then make Q true. You can either make R true or R false. So we should add two more paths at the bottom of this branch. One to represent the scenario where you go on to make R true, and the other to represent the scenario where you go on to make R false. Of course, whatever you decide to do with P and whatever you decide to do with Q, you have two options for what to do with R, so we should add the same two extra paths to the bottom of each remaining branch on the tree. There are now 8 different paths that you can follow from the top of the tree to the bottom. One path is to make P true, Q true, and then R true. So that's one possible valuation of those atoms. Another path is to make P true, Q true, and then R false. That's another possible valuation. A third path is to make P true, Q false, and then R true, and so on and so forth. The 8 paths down the tree capture all the possible ways of assigning truth values to the atoms P, Q, and R. Now, what if you had a formula with 4 atoms or more? Then how would you figure out what all the possible valuations of its atoms are? Well, suppose we're dealing with a formula with 4 atoms, P, Q, R, and S. You could add 2 more paths to the bottom of every branch on our tree. One to represent the scenario where you decide to make S true, and the other to represent the scenario where you make S false. Then there would be twice as many paths down the tree as before, so there would be 16 ways to get from the top to the bottom as opposed to 8. And each of those 16 paths would represent one way of assigning truth values to the atoms P, Q, R, and S. If you were dealing with a 5th atom, you could add another 2 paths to the bottom of every branch, and that would result in 32 different ways to get all the way down the tree. And you could read off all the different possible valuations for 5 atoms by going down each of those 32 different paths. But rather than continuing to extend this tree, which gets rather unwieldy, here's a trick you can use. Notice that if you have just one atom, then there are two possible valuations of it. It can be true or false. If you have two atoms, then there are four possible valuations of those two atoms. If you have three atoms, then there are 8 possible valuations of them. And every time you add another atom, the number of possible valuations doubles. 4 atoms have 16 possible valuations, 5 atoms have 32 possible valuations, and so on. In general, for n atoms, there are 2 to the n possible ways of assigning truth values to them. So if you want to write down all the possible ways of assigning truth values to some group of atoms, here's another way to do it. If you have n atoms, you could label them P1, P2, and so on, then you know that you'll have 2 to the n different valuations of them. So you'll be creating 2 to the n rows in your table, 1 for each possible valuation of the atoms in question. Go to the last atom in your list, and in its column, write alternating T's and F's until you've made 2 to the n entries under that column. Now go to the atom right before that one, and in its column, write 2 T's followed by 2 F's, followed by 2 T's, followed by 2 F's, until you've again made 2 to the n entries in that column. Now move a column to the left again, and once again double the number of consecutive T's and F's that you write. So this time you'll write 4 T's followed by 4 F's, followed by 4 T's, followed by 4 F's, and so on. Continue that process until you've filled out the column for each atom. That will give you all the possible valuations of your list of atoms. So for example, suppose I want to write down all the possible valuations for 4 atoms, P, Q, R, and S. I know there should be 2 to the 4th, so 16 different rows in my table. So I start in the last column for S and write down alternating T's and F's until I've got 16 entries. Then I go to the column for R and alternate between 2 T's and 2 F's until I complete 16 entries. Then I go to the column for Q and alternate between 4 T's and 4 F's until I have 16 entries. And finally, I go to the column for P and I alternate between 8 T's and 8 F's until I have 16 entries. That gives me all 16 ways of assigning truth values to those 4 atoms.